Hi, I'm Megan and I'm going to be doing number 46. So for number 46, we're going to be solving for tension 1 and 2 with the ball rotating along the axis. The dimensions given allows us to create an imaginary line which we will call r, which is the radius. Now that we have two thetas to work with, we can solve for r using Pythagorean theorem. So r would equal 0.866 meters. So now we are going to create the force statements. In the x-axis, the forces would equal T1 cosine theta, which is this, plus T2 cosine theta, which is this. We're going to equal this to centripetal acceleration, which would be mv squared over r. In the y-axis, it would be T1 sine minus T2 sine minus Fg, because Fg, T2, and T1, since it's not moving up or down and is only going around, those forces will cancel out. So now we're going to isolate for tension 1 using the force statement. So it would be T1 sine theta equal to T2 sine theta plus Fg. So we're going to move the sine over. So T1 would equal to T2 sine theta plus Fg over sine theta. So we're now going to simplify it. So it would be T2 plus f of g over sine theta. So now T1 equals to T2 plus the .3, which is the mass, because force of gravity is just mass times gravity, times 9.81 over 0.5. And we got the 0.5 from sine of theta, which would be right here. So we're going to get T1 equals T2 plus 5.88. So now we're going to plug this into right here, which is our x-axis force statement. So then it would be T2 plus 5.88 times 0.866, because cosine would be right here, plus T2 0.866. And so then we would equal it to centripetal acceleration. And in order to get centripetal acceleration, it would be 0.3 times 7.5, which is constant velocity, squared over 0.866, which is the radius. That will equal up to 9.4862. So then this whole equation would equal to 9.4862. So T2 in the end would come out to 8.31 newtons. So now in order to find tension 1, we're going to plug in T2 into this formula right here. So then it would equal to T1 equals to 8.31 plus 5.88. T1 would equal to 4.2 newtons.